Okay, so this is just a video for you guys to reference to help you kind of get through this extra practice right here. Okay, I will be posting this key and the video this afternoon. Okay, so again, we're just kind of looking at geometric vectors. Now we're looking at how to, draw vectors, how to add multiple vectors together, how to get the resultant. Okay, and so first thing I always want to do is when I'm given vectors is I want to find their components. Okay, so remember, how do we find the components? Remember, you go from the initial point to the terminal point here, right? So initial to terminal, and the components for m would be what? It'd be 1, 2, 3, 4. So we would write our components as 4, 0 for m. Okay, 4, 0 for m because we just went right 4 and that's it. Okay, for n, we go from our initial here to our terminal, and so we're going to have 1, 2, 3, and so our components then for vector n are going to be 0, 3. When it's slanted like this for P and R, you've got to find your components by drawing your triangle, your right triangle. So we started our initial here, and it looks like we're going over 1, 2, and then up 1, 2, 3, 4. So then it looks like for vector P, our components are going to be 2, 4. Now recall, guys, when you're doing R like this, you start at the initial, you go to the terminal there, okay, and we go this method. So it looks like we're going to the left 1, 2, 3, 4, 5, and then it looks like we're going up 1, 2, 3. And so our components then would be -5, 3, because we went left 5, up 3. Okay? All right. So let's go ahead here and let's answer some of these questions. Okay? What is the magnitude of m? Okay, so recall, how do we find the magnitude? We take the square root of the components squared added together, right? So we're going to square both components. So 4 squared plus 0 squared, add them together, and then take the square root of that. And when you do that, you end up with the square root of 16, which is equal to 4. So then it says, what is the direction? Okay. Well, we can tell, okay? If we know exactly what the direction is, okay? All right, we just say when it's not slanted like in vectors P and R, okay, we can just say like due east. Okay? So we just say due east, because we know it's exactly going east. Okay? If you wanted to put 0 degrees, I guess you could say 0 degrees due east, okay? Because if you think about it, the direction, the angle direction there, okay? All right, now it says, look at what is the magnitude of n. So again, same thing, right? I'm just taking the square root of my components squared added together, so it's going to be square root of 0 squared plus 3 squared. And so when you do that, you get the square root of 9, which then equals 3, which we can tell the length of that line, right? Because we know it's just going up 1, 2, 3. Now, what is the direction then of n? Okay, well, we would say 90 degrees due north. Okay, so we'd say 90 degrees due north, all right? Because look what's happening. This is going up north. Think about it. So when you think about your directions, guys, and I'll just write it here for you again just so you remember, but it's north, east, south, west, right? And just to recall, remember, this is 0 degrees here, 90, 180, 270, and then if we make it all the way close back around 360, right? So that's kind of how we determine that, and we need to really understand that for these next couple of questions here, okay? So it says, what is the magnitude of P? So again, we're taking our components, okay, and recall, and I want you to remember the notation, so if I just ask you that instead of giving you the actual lingo for it, you know what I'm asking you to find. So when you see something like this, that means magnitude. So you're going to take the square root of the components, so 2 squared plus 4 squared, and so when you do that, that's going to give you the square root of 4 plus 16, so 20, and we want the exact value, okay? We want the exact value, so the magnitude then is going to be, let's see, how does that simplify? Sorry, 2 root 5, so that's our magnitude, okay? Now when we think direction, okay, guys, this is what I want you to get comfortable with because you're not going to be 100% sure about this. But when you think direction, okay, you're just doing tangent, right? So we're going to go tan inverse. Okay, remember direction is theta, sorry. So theta equals tan inverse, okay, of, it's always going to be your vertical component over your horizontal component. So it's going to be 4 over 2. Okay, now let's go ahead and plug that into our calculator. So tan inverse here, 4 over 2, close parentheses, and when I hit enter, there we go, I got 63.4, we'll just say 63.4 degrees. Okay, now what quadrant should we be in though? Look at the direction this is going. Remember, this is your origin. Where is it going? It's going to the northeast. So anything in the northeast should be in quadrant 1. And so when we did tangent there, that answer is okay. That answer is okay because we know tangent works in quadrant 1. And so when you talk about direction though, when it's not, say, a due north, due east, due south, due west, you have to write it like this. You say north 63 degrees, 63.4 degrees east, okay? And so what that's telling me is, guys, what that's telling me is I'm just going, I'm closer, what it's telling me is that, think about this, okay, right? This is supposed to be 0 to 90, okay? That 63 degrees is closer to north. Okay, that 63 degrees is closer to north, and so that's why we do north 60 degrees, 0.4 east. Okay, if it was closer to east, we would start off with east, the degree, and then closer to north. Okay, so that's just kind of how I see it. So just really, really pay attention to that. Okay, it's going to take a little bit of practice. Okay, all right, the magnitude for R. Again, we're taking the square root. Now this time you've got a negative component, so please make sure you put a parentheses around it. Okay? Because if you don't, it's going to give you a negative number for some reason in the calculator, and we know that's not true. Okay? So that's going to give you the square root of 34. 25 plus 9, you get the square root of 34. There's your magnitude. Okay, direction, same thing. We're going to do tangent, so we're going to do theta inverse. So tan inverse, and we're going to do a vertical component over our horizontal, so 3 over negative 5. So let's go ahead there and let's plug that into our calculator. So we're going to do tan inverse of 3 over negative 5. And there we go. So we got negative 30 point, let's just say, yeah, let's just say we'll just say negative 31 because that's what it rounds up to. So we'll say negative 31 degrees. Now here's the deal though again, right? Where are we supposed to be at? Look at this vector here. This vector is going, based on our directions up here, right? It's going northwest. It's going northwest, right? Okay. So if we know we're going northwest, based on our directions here. What quadrant are we supposed to be in? We're supposed to be in 2. So this is where you use the rule, right? So again, this angle does not, by doing tan inverse here, because it doesn't work in quadrant 2, it's not going to yield me a good angle in quadrant 2. So I have to then add 180 degrees myself. And so when I do that, I'm going to get negative 31 plus 180, and that's going to give me 149 degrees. Okay? Now, this is where you have to make a judgment call, and you have to ask yourself this. You say, okay, is that 149 closer to west, or is it closer to north? And in this case, okay, that 149 is going to be closer to the west, and so you're going to write it like this. You're going to say west, 149 degrees north. And so what that means is that this direction, okay, is closer to west than it is north. Okay? And so that's how that looks. Okay, that's how you're going to describe direction for me. Okay? Now, which problems required more work? 6 and 8. Because we want an accurate direction. We want it to be accurate, right, guys? If I'm telling a plane, okay, if I am, because again, right, how do these planes track exactly where they're going? It's not like these pilots are following a map on their phone and saying, okay, yeah, if I just stay directly on this road, right? I mean, they're in the air, right? And so what these air traffic controllers tell them is they say, hey, I want you to turn 149 degrees towards the west. I want you to start going west 149 degrees towards north, right? And that's what they're going to do, right? They're going to take that turn, and that's going to help them stay on the exact path as to where they need to fly to. Okay? All right, so let's recall again now drawing vectors, right? So it wants me to draw 3M. So just make sure, guys, when you draw this, okay, make sure when you draw this, okay, you have enough room to draw all 3 vectors on there, okay? So I'm going to start right here at my initial point. And then what is my components for M? Well, my components are just right 4 over 0. So I'm going to go 1, 2, 3, 4. Terminal point, draw an arrow, and then label M. Okay? I'm going to start where I ended that first M and go same components again. 1, 2, 3, 4. Label that vector M as well. So there's another M there. And now I need to do one more because it wants the third one, right? And so we're going to go 1, 2, 3, 4. And there, that's now my terminal point. Okay, and so all it wants me to do is it just wants me to draw them, right? Okay, but now if I wanted to know what the components were, well, what would the components be? Well, when you have a horizontal or vertical line, it's really easy to tell. You just count over, right, until you get to that terminal point. And so my component would be 9, 0. Would be 9, 0. Okay, and then if you were to find the magnitude of 3M, you would just square the components, add them together, and then take the square root, which that would yield square root of 81, which is also equal to 9. Which, because we can like we know the distance of our vectors if they're always going to be horizontal or vertical. It's only when they're diagonal we're not 100% sure. Okay, so it says it wants me to draw 1/2 P. So that's like doing this. That's like putting a 1/2 out here in front of the components for P and then distributing that 1/2 through. So when you do that, like if you're looking right here, what is 1/2 times 2? Well, that's just going to give you a 1. And then what is 1/2 times 4? 2. And so my components for 1/2 vector P are going to be 1, 2. And so we can start that anywhere. So let's just start it right here. So our initial point, I'm going to go over 1, and then up 1, 2. Draw my terminal point there, and then just connect the two. And now if you wanted to find the component form, which we already did, find the magnitude, it's already described there in problem 9. So same process. But I'm just asking you really to draw. Okay? All right, now it's asking us to draw negative r. So all we're doing is we're doing opposite of the original r. Whenever you see a negative sign in front of a vector, that means opposite vector. Okay? So then my components then for negative r are just going to switch. So now it's going to be positive 5, negative 3. All I did was I flipped the components from the original r, because that's all that means. A negative sign in front means opposite. Okay, opposite. All right, so we're going to start up here with our initial point, and I'm going to go over 5 to the right 5. 1, 2, 3, 4, 5. And then I'm going to go down 3 because it's a negative 3. 1, 2, 3. Draw my terminal point there and then just connect them. Okay? All right, let's move on to number 12. Okay, so this time now we're adding two vectors together. Okay, we're adding two vectors together. Okay, so we want to do m plus n. Okay, so again, make sure you have enough room for these. So our components for m, so we'll just start, let's just start here. Okay, I just want to make sure. And again, guys, how I know where to start is because I've done so many of these. Okay, I've done so many of these. All right, okay. And so we're going to start here, our initial point. Okay. And so we're going to go over 4, right? Because it was, or no, what was the components? Yeah, components for, oh shoot, I messed up on 3m too. That should be, that should be 16, 0. I'm sorry, shoot. I apologize about that. What is the square root of that? That's 2. Yep. I'm sorry about that, guys. Okay, so go back down here to 12. So we're going to start down here, and we're going to go right 4 because that is the components to draw vector m. So we're going to go 1, 2, 3, 4. Terminal point there. Connect the two, draw them, and then I'm going to label that vector m. Okay, and then for n, the components are just from the end of this vector, we're going to go up 3, right? So we're going to go 1, 2, 3. Terminal point there, connect those two, arrow, and then label that vector n. Now, it says it wants us to label our resultant vector a. So how do we find our resultant? Our resultant occurs from the initial point of the first vector to the terminal point of the last vector drawn when you're adding multiple vectors. So we're going to go from the initial to the terminal, and then I'm going to label this vector A. I'm going to label that vector A. Okay? That's our resultant. So now, what does it want us to do? Okay, so what we need to do is we need to find our components. So to find our components, okay, we're going to start from the initial and we go to the terminal. We're just connecting it. So we're going to go up, it looks like 1, 2, 3, and then over 1, 2, 3, 4. Okay, so our components then for vector A look like this. Remember, you write horizontal first, vertical second. It looks like over 4, up 3. Okay, how did I do that? I went from the initial point, I went up 3 over 4. We always write horizontal first, vertical second. Okay, I just went from the initial to the terminal after I drew M and N. Okay, so now what is this asking? Horizontal displacement. Okay, horizontal displacement is the same thing as component. So what was my horizontal component? 4. Vertical displacement. Displacement is the same thing as component. What was my vertical component? 3, right? So then how do we find the magnitude? We take the two components, we square them, add them together, and then take the square root of that value. And so that's going to give you 16 plus 9 there, which is the square root of 25, which then equals 5. So then what is our direction? Well, direction, remember we got to do inverse tangent. So we're going to do inverse tangent. Remember, I can't really, I do kind of have this picture to look at, guys, but again, whenever we're doing direction, it's always going to be our vertical component over our horizontal component since we're using tangent. So 3 over 4. And so let's go ahead there then, and let's go tan inverse. 3 over 4. Close parentheses. And there we go. So we got 36 point, we'll just do 9 degrees. Okay? Now, how do I know if that's the correct answer now? Well, look at your resultant right here. Look at your resultant. What is it doing? It's going to the northeast. So since it's going towards the northeast, we should be in quadrant 1, which we know that tangent works in quadrant 1. So therefore, we know this is a good answer. And so we're going to write the direction like this. We're going to write east, 36.9 degrees, north. Why am I writing east first? Because that 36.9 degrees is closer to east. You're going to start off going east and then move more towards north. Okay? All right, so that is 12. Let's go ahead and let's look at 13, and that'll be it. And then I'm going to let you guys, I'll post the key obviously for 14 through 20, but well, really 23, okay? But I'm going to let you guys try and figure that out yourself, okay? The video is just going to help kind of assist with the first page here. All right, so 13, it says, draw the vector diagram of B equals P R. So we want to do vector P plus R, okay? So with vector P, what were we doing? We're going northeast. And then with vector R, we're then heading northwest. Okay, so I think what I want to do is I'm going to start down here. I'm going to start down here for my initial point. And then for vector P, what was our component? It was right 2, up 4. So I'm going to go over 2, up 1, 2, 3, 4. Terminal point there, and connect. Well, that's right now so far that's my terminal point because all I've drawn is what? Vector P, and so then I'm going to label that. Sorry, I'm going to need to flip it a little bit here so I can label. I'm going to label this vector P. Okay, so there's vector P, and so from the end of, and I'm going to erase that terminal point because I've still got one more vector draw. I have to draw now R, right? And so, what was vector R? So from the end of vector P, I'm going to use the components for R to draw R, and so R was left 5. So 1, 2, 3, 4, 5, and then up 3. 1, 2, 3. Connect those. And there you go. So there's my terminal point. Okay, there's my terminal point right there. And I'm going to erase these so you don't get confused by the By components, we're going to go ahead, we're going to label this vector R. This is how I want you to do it, okay? I'm expecting you to label them for me so I can see how you're drawing them correctly, okay? And so now where does our resultant come from? Our resultant comes from the initial point of the first vector to the terminal point of the last vector drawn. So we're going to connect those, draw an arrow, and we're going to label this right here vector B. Okay, so my resultant is right here. I'll try and make it darker if I can. I know I had colored pencils yesterday. I apologize. So that's our resultant right there, the really dark shaded in line, the heavier line. Same thing with this one right here. Okay, the really dark shaded line, that's your resultant, the thicker line. Okay, so now we need to go ahead and we need to look at find our displacements, our components. So to do that, we go from the initial point. Let's say we're going to go 1, 2, 3 to the left, and then we're going to go up 1, 2, 3, 4, 5, 6, 7. So it looks like our component then, since we went left, negative, and then up 7. Okay? So I'm not going to go ahead and just scratch out displacement this time. We know displacement is just asking you the same thing as the component. So what was my horizontal component? I went left 3, so we're going to write a negative 3 there. What's my vertical component? 7. Okay, and now to find the magnitude, we're just taking the components, squaring them. So negative 3 squared plus 7 squared under the square root sign. Okay, to make that even easier, I'm just going to use my calculator. And so I'm going to do square root. Okay, put the negative 3, negative 3 in the parentheses, plus 7 squared. Hit enter and we get square root of 58, so that's our magnitude. That's how long our resultant is the square root of 58. Okay, for direction, we're going to go ahead and use tan inverse. So we're going to go tan, so theta, tan inverse. Okay, again, it's always your vertical component over the horizontal. Do not get that mixed up. If you get that mixed up, it's going to mess you up. So again, let's go ahead here, back to the calculator. We're going to go tan inverse of 7 over negative 3. Close parentheses, hit enter, and I get negative 66.8. Now, this is what you have to ask yourself. Look at your resultant and say, okay, where are we going? Okay, where are we going? Well, my resultant looks like it's moving towards the northwest. And so when I think northwest, I go all the way back up here and I say, okay, northwest, what quadrant is that supposed to be in? It's supposed to be in quadrant 2. Well, we know because tangent doesn't work in quadrant 2, we're not going to get an accurate answer. And so what we must do is we're going to take this negative 66.8 degrees and we're going to add 180 degrees in it because I want to get an angle in quadrant 2. So go ahead, negative 66 point, or just do negative 66.8 plus 180. Hit enter and there you go. So 113.2 degrees. Okay? And so what's going to happen then, okay, what's going to happen is that now when we write this direction, that 113, is that closer to the north or closer to the west? And in this case, it's closer to the north because north is due 90 degrees east, right? And so we're going to say north 113.2 degrees east. Okay? All right, so that's kind of giving you an example of how to do everything. Okay? Same process really on the back page, just more practice. Okay, so I encourage you to try this. Like I said, I will post the key this afternoon with this video. Okay? All right. Thanks, guys. Have a great weekend, and I will talk to you on Monday.